Hi everyone, in this video we're going to look at section 10.2, hypothesis tests for a population proportion. So in 10.1 we were introduced to hypothesis testing. We talked about the language, what does the setup for a test look like, what are the conclusions that we draw from a hypothesis test, and here we're going to look at how to actually perform the test as it relates to proportions. And the most common, I think, application to this is related to like politics and stuff. They're the easiest one maybe, and we'll start out with a scenario before we get to the formal process. And we have a politician wants to know if a majority meaning more than half of her constituents favor a certain policy. I get emails and letters from Fred Akshar all the time that have polls, and he wants, as one of his constituents, feedback on how I feel about certain things, and that's going to help him to determine what policies he pushes and votes for ultimately. Okay, so what that politician does is they hire a polling firm. Fred Akshar has people that do this for him, that work for him, or they hire a firm to do this, and they get a sample of 1,000 voters, and of those 1,000, 534 are in favor of the policy. 534 is clearly more than half, 53% is more than half, but is that strong enough to suggest that among all of the registered voters in that area, more than half favor the policy? Would it be unusual to obtain a proportion, and this is the kind of statistical question that we look at, would it be unusual to obtain a sample proportion higher than that 53%? Okay, so that's the type of scenario that we will address in this section. Okay, and there's two different approaches that we can take to looking at, or to performing hypothesis tests. One is called the classical approach, and this one is the one that I am going to more heavily focus on and ask you questions about, especially on our test. The MyMathLab homework will address both approaches. The classical approach is, I think, more intuitive, easier to understand, easier to determine. The p-value approach is more common in like real statistics, but that's because it's more software based. Okay, so I will look at the classical one more in sample problems and that we look at in this video, as well as the questions that I ask you on the test. So make sure that you understand this one first, and then secondly the p-value approach. Okay, and so the classical approach is what we look at is if our sample proportion, that 53% from the last example, is too many standard deviations from the proportion stated in the null hypothesis, that's the case where we reject the null hypothesis. Okay, that's called the classical approach. So if my sample proportion is too far away from the one in the null hypothesis, then we reject. The p-value approach is, the p is related to probability. If the probability of getting a sample proportion as extreme or more extreme as low, then the one obtained is small under the assumption of the null hypothesis. You reject the null hypothesis. This one we'll look at in a little bit more detail more toward the end of the video, or maybe I'll break it and take this in a second video with the p-value approach. Okay, now here we get to the big formula slide. There's a ton of information here. This is in your text on page number 440. You can pause it here. You can print from the PDF of the notes. But this is really the guy that you want to use as you go through the homework questions. You can use the actual examples that I go through in a little bit, but this has everything that you're going to possibly need. Okay, and so I'll kind of go through this, highlight the important stuff to kind of make a note of. All right, so our steps here, I might use a little bit different order as I go through examples, but generally speaking, these are the steps. Step one, we write down our hypotheses. Is it left, right, or two-tailed? That's step one. We did that in the previous section. We'll do it again in this section. Step two is our level of significance alpha, and it says select, but really we'll be given a level of significance in the homework question or the sample problem or the test question. So we'll address that in step two. Step three, we compute the test statistic. So this is our z-score, and this is a fancy looking z-score formula. Previously, our z-score formula, right, it's z equals x minus mu over sigma. That's our z-score formula back in chapter 3, I think, right? Here, the x is the sample proportion. The mu, is the hypothesized proportion, that's the P naught right there, P0. And then sigma, the standard deviation, well, there's our standard deviation formula from chapter 8. And notice that in that formula, P0 is from the hypothesized proportion, from the null and alternative hypothesis. Okay, so that gets in that z-score formula, it's in 1, 2, 3 different places. Okay, so that's our step 3. And then they say use table 5 to determine the critical value. Now, I like to do this, and so I'm going to label it that way. I like to do this step, draw my bell curve, and get my z-score in step 2. When I'm talking about the level of significance, I'm going to, at the same time, write down my bell curve and find my z-score. Okay, so that's something that I do a little bit differently. And then step 4, you compare the values, right? This is really formal. Basically what it means is if your test statistic, this z-score up here, falls in the critical region down there, then that's the case where you reject the null hypothesis. Okay, there's all these inequalities here that we can like try and memorize and stuff, but I don't like that. If your test statistic is extreme, falls in the shaded critical region, reject the null, and state a fancy conclusion. Write your sentence. Okay, so those are the steps that will follow. That's the classical approach. And like I said a minute ago, I will address the p-value approach, but not in this video. We'll save that for a second video. Okay, let's look at our first example here. The ACT has established that 22 is the minimum score on the math portion of the ACT exam for a student to be considered prepared for college math. That's the setup. And prepared for college math means 75% probability of success in college algebra. And we are talking about an official with the Illinois State Ed Department wonders if less than half, that's really important, of the students in her state are prepared. So she gets a sample of 500 records of students who've taken the ACT and finds that 219 are prepared for college math. That is less than half. But does it represent significant evidence that less than half of the students in the state are prepared for college math at the 5% level of significance, right? 219 out of 500 is less than half, but is it an extreme enough of a result to draw some important conclusion? Okay, that's what we're looking at here. Now, let's get to the work in this problem, and I want to move this over there, make it a little bit smaller, and I'm going to do my steps on the right. What I've got in the box there, that's my fancy concluding sentence. All right, step 1, null hypothesis, H0, alternative hypothesis, H1. This is P equals 0.5, 0.50. That's because of this, half. Half is 50%, and because it says less than half, we're testing the left tail. This is a left tail test. Okay, that's step 1. There you go. You get credit for doing that little bit of work. Step 2 is our level of significance. So I'm following the steps from the previous slide, and they tell me that alpha, and where is it? Down at the bottom of the problem, is equal to 0.05. Alpha is 5%. Okay, so here's where I go and stray from the steps on the previous slide a little bit. I'm going to now draw my bell curve like so. Kind of poorly, but it's a decent bell curve. I'm going to label the left tail, right? This is alpha equals 0.05. I'm even going to shade that tail in a little bit. Okay, and there's some z-score, z-alpha, that corresponds to that 5%. Now, because we're talking z-scores can be found on table 5, table V, table 5, and there is the cheat sheet at the bottom, the common confidence level interval values, and also common ones for hypothesis testing. So if you look at table 5, go down to the bottom, z alpha is equal to, let's see, for a left tail test, 5%, it's negative 1.645. That's the z-score corresponding to right, whoops, I didn't want to highlight that, corresponding to right there. There we go. There's my z-score. That's the critical value. The blue shaded, now the red shaded area, that's the critical region. in step 3, when we do our test statistic, anything that falls inside of there, we reject the null. Let me label my step 2. This is the test statistic. Oops, no, that is the level of significance. Level of significance. And then step 3 that I'm going to do now is my test statistic. Okay, what does my sample actually say? Where does that fall in my distribution? Okay, so the formula for that, let me move this up a little bit, is z equals, it's p hat minus p naught, p0, over the square root, p naught, times 1 minus p naught, over n. Now, we only need to find one thing before we can plug everything in there, because the p naught that appears in 3 different places, that's the 50%, the 0.50 from the beginning of the problem. The only thing that we don't yet have is p hat, the sample proportion, and that is our 219 that are prepared for college math out of 500 in the sample, and 219 divided by 500 is 0.438. 0.438, and that's what goes right there. So I'm going to substitute in here and then use my calculator. 0.438 minus 0.50 over the square root. 0.50 times 1 minus 0.50 is 0.50 over 500 in my sample. And when I type that into my calculator, I get, let's see, negative 2.77, and I'm going to go 2 decimal places there. I could go a third, but we'll leave it at that. One note with typing this in, you could do the numerator first and then divide by the denominator, or you could type it all in at once, but you do need an extra set of parentheses around the numerator. One thing that I want to add on here from the formula that I left off, the test statistic, we do get a little subscript of 0 there, z naught. It's not a huge deal. The subscript z alpha is for our level of significance, and then the subscript z0 is our test statistic. Just want to make a note of that to be consistent. Okay, so how do we draw our next conclusion, right? This is the case. Now we have to compare where we fall in our distribution, and I'm going to draw lines all over my work. That negative 2.77. Where does it go on the bell curve? So I'm going up here. I'm going up here. Where am I on my bell curve? If I go over to the left because it's negative, I got to be beyond that negative 1.645. It's somewhere over there. Okay? So here's the conclusion that we draw. Because our p hat, the sample proportion, is beyond the cutoff, beyond the critical value, it is extreme enough by our standards that we've set. Step 4, we reject the null hypothesis. We reject the null hypothesis because we fell in that critical region. If that z-score had been over here, over here, over here, over here, anywhere else beyond that isn't beyond negative 1.645, you don't reject the null hypothesis. Okay? That's that part. And then finally, step 5 is what's been here under the box this whole time. So let's make that go away. Step 5, zoom in on it. There is sufficient evidence at the 5% level of significance to conclude that less than half of the students in Illinois are prepared for college math. That's the super fancy sentence. It's got all the key buzzwords in there. Get comfortable with writing your own sentence, but you have to be able to draw that final conclusion. What does it mean about that population? That's the goal here, is to understand what all of the work on the right means. All right, in our next example, we have a question about gun ownership. Right? And what it says is a statement first about all Americans. 46% state that the right to own guns is more important than controlling gun ownership. And then we take our sample data, right? Our sample data, and we survey 1,267 Americans with at least a bachelor's degree. Found that 559 believe the right to own guns is more important than controlling gun ownership. So, does that sample suggests that the people with bachelor's degree, the proportion of Americans with bachelor's degree, feel differently than the general population? and use the 0.1 10% level of significance. So as I read that, I highlighted the key stuff, and now we're going to use all that as we go down and perform our hypothesis test. Start out with the null and alternative hypotheses. P equals. So what is it? It's the 46%. That is the statement that we're comparing our sample against. Alternative, P does not equal 46% because I found the word differently. So that tells me it is a two-tailed test. All right, and then that's step one. Step two, level of significance. They give me alpha is 10%, 0.10. Move this up just a little bit. But that 10%, because we're a two-tailed test, that gets split up into two tails. So this is a negative z alpha over 2 over there and a positive z alpha over 2 over there. Because I'm splitting it up into 2 alpha over 2 because there's 5% in the right tail and 5% in the left tail. If you use the table at the bottom of table 5, 10% two-tailed, they tell me plus or minus 1.645. Positive over there, negative over there. And let me just shade my critical region with red, because that makes it sound bad. There's critical region there, critical region over there. It should look a little bit more symmetric, but I do my best to draw. All right, that's step 2. Step 3, test statistic. All right, z equals p hat. I don't have that yet, so let's find it. P hat is 559 divided by 1267. And then I'm going to do that in my calculator right now because I don't have it in front of me. And it's 0.441, 44.1%. So when we plug into our formula, and you can, maybe you have it in front of you, you can see if you can pause the video maybe and see if you can plug in correctly on your own. But I'm going to go 0.441, 1 minus 0.46 divided by the square root, 0.46, 1 minus 0.46 divided by n is 1,267. All right, type that into your calculator in 2 steps. Or if you want to do 1, make sure you have that extra parentheses. And I got a z score for my test statistic of negative 1.36. 1.36. Okay, so what does that mean? I take that negative 1.36, bring it over to my distribution. Where does it fall? It's past that. We keep going. It's probably right about there. There's my negative 1.36. It's not that extreme. It's not beyond the cutoff. So what does that mean? It means that we do not reject the null hypothesis. That's what it means. Don't reject the null. There's not enough evidence to conclude that the proportion of Americans with bachelor's degrees feel differently than the general population on this topic of gun control. Okay, that's the big fancy conclusion to the problem. All right, let's go through one more example in this video before we cut it short here. An airline claims on average that 5% of their flights are delayed each day. On a given day, I go and I record some data. Out of 500 flights, 50 happen to be delayed. And we're going to test the hypothesis that the average proportion of delayed flights is more than 5%. And we're going to test it at the 1% level of significance. So there's only 1% chance that that this gives the wrong conclusion. All right. So our hypotheses, step 1, the null, the alternative hypothesis is P equals 0.05. That's the 5% up here. That's the claim. And then we're testing whether it's actually more than 0.05, greater than 5%. The level of significance, alpha, is 0.011%. We're given that. But in this step, instead of just writing that down, we're also going to draw our distribution, label that 1% alpha. That would be z sub alpha. Z alpha is some number that we're going to look up on the table that puts 1% of the distribution to the right of that tail. All right, and that z-score, if you look at the bottom of table 5 again, is, let's see, right tail 1%, 2.33. So 2 1/3 is my z-score there for the level of significance. And then the test statistic z-score, z0, is equal to, well, I don't have my p-hat yet. That's 50 out of 500, which would be 10 out of 100, also known as 10%, 0.10. So 0.10 minus 0.05, that's p-hat, minus p0, the 5%, divided by the square root of 0.05, 1 minus 0.05, divided by the 500 flights in my sample. Now, when I type that into my calculator, holy cow, I get a z-score, z0, of 5.12. So is that beyond the level of significance there, the critical number, the critical value? I think so. It's somewhere way over here to the right in my distribution. So because it's in that shaded area, it's way in that shaded area, we reject the null hypothesis. We super reject the null hypothesis. Reject the null hypothesis. Okay, so is there enough evidence to say that their average, their claimed average, is wrong? Yeah, I would say so. There is enough average. So there is enough evidence. So something like there is sufficient evidence at the 5% level of significance to support the claim that more than 5% of their flights are delayed each day. We don't know that it's 10% here. That's not what we're trying to figure out. We're just trying to say that the claim is wrong, and we do have evidence to support that. Okay, that's the end of this video. I will be posting a Minitab tutorial video on how to do hypothesis tests in Minitab, as well as a follow-up video Wednesday for Wednesday's quote-unquote class. And that will focus on the p-value approach. Okay, so stay tuned for that. Thank you for listening. Have a wonderful day.